Hello, we are Billionaire Fortnite gamers, and our app is called Cranking Out Strokes. To explain that quickly, cranking 90s is a Fortnite term that is a fast and efficient building method for gaining height vertically. It's a very important technique to master, but instead of mastering cranking 90s, we're mastering strokes because we're an art app. So to show you what the user's first introduced to, they'll see the splash screen on our left with some AI generated art. Once they tap that, they will be brought to the login screen on the right, which again is as simple as we can make it. You'll see some of the animations we have during our demo later. After logging in, you're greeted with the image gallery screen. It has some controls in the top left. There's the local selection, which shows all local images, and then the cloud selection, which shows all the cloud images. On the right, you can see a little screenshot of the loading screen, which again is as simple as we could make it. Once you either tap New Drawing or tap on the image you would like to edit, you're brought to our drawing screen. On the bottom, you can see the simple controls we have for choosing. There's a slider for brush size, and then you can choose between a circle and a square brush. The color button will bring up the color selector on the right, and then we have controls for saving. So that's our UI.
Now for the software architecture of our project, we decided to use MVVM architecture for our project. In the previous section, our view and UI was covered extensively, how users will interact with our app to draw, upload images, sign into their account, etc. This section is going to dive more into depth on our view model and model. Our view model is kind of an in-between our view and our model. It handles all the UI logic and all the data that the UI might need, such as like brush size, brush shape, how to modify those settings, etc. It also makes requests to our model for any information that the UI might need, such as requesting from our direct file storage in RoomDB for local files, requesting from our Firebase database to get cloud images. Our model has a lot of moving parts. Like I said, there's a file storage, RoomDB locally for local images. There's also the Firebase stuff for cloud images. To be more specific on the Firebase architecture, we require all users to create an account through our app to be able to log in and view their images and cloud images. That's handled through Firebase. You create an account, you just log in every single time. The Firestore database, we upload author information, image name information about all the cloud images. And then the Firebase storage is where we actually upload the images and we make requests to both to get cloud images, make sure everything's synced, etc. With this type of project, since we're making a lot of requests to different databases and parts in our model, these requests are pretty slow because Firebase over the internet, direct file storage, pretty slow because it's on disk too. We have to use a lot of live data and coroutines so that our app's as responsive as possible for users because we didn't want to diminish the user experience. So a lot of our view model and model things happen in coroutines and stuff so that the app feels lively and all this information could be gathered while the user can still do stuff and then it's uploaded when we get that information.
Hello, and welcome to the testing section of our presentation for cranking out strokes. So, basically, we tried to focus our testing on the drawing view model, mainly all of our models instead of things like the composable, since we thought that those would be semi easy to test via the emulator and just messing around in our GUI. We did both individual components and integration tests. This helped us verify that each individual component was working first, and then we were able to put these all together to verify that when they worked together, they also were working. Our primary focus was testing things like, for example, the brush shape, the size, and color selection. We also focused on image creation, saving, and loading. I feel like this helped us early in the process of making the app so that we could catch bugs early and make sure that we made that sure that every single feature behaved as expected. So a large part was using RoboElectric. RoboElectric is a framework that allows us to simulate Android behavior on the JVM. It made it a lot faster to test since we didn't have to by hand go through and test everything on an actual device or an emulator. So that was really nice. RoboElectric was nice to test things like picking a brush shape or size since that depended on live data values. So that worked out very well, and these were things that were in our view model. We used a lot of live data and coroutines in our app. So RoboElectric was a powerful tool. It did have some limitations since it's not as great with newer Android APIs, but it allowed us to test everything efficiently, I believe.
All right, I'm going to give a quick demo here of our drawing app. This is our splash screen. If you tap it, you're taken to the login screen where you can enter and get this annoying stylus thing every time. You can enter your email, and if you are super smart and make a mistake, you will get a little error animation and the error message will pop up. But if we go ahead and enter our email correctly, we will be taken to our image list screen where you can see my local images. That's because this is selected here. You can also tap this to be taken to the cloud screen after a brief loading screen, and you'll see everything that's in the cloud. We can open one of these up and we go to our drawing screen, and you can see we can change our brush size, we can change color. We also have a different, we have a square brush. So we've made some changes to this. Now we can save it locally. And if I hit the back button, we're taken back to our cloud screen. You don't see it, but then if you go to local, there she is. So we can also do a new drawing, add some texture to it, so we have something to look at. And then if we hit save to cloud, we can go back and we'll see that that was also saved locally because cloud images are automatically saved locally. But then if we go to cloud, we will refresh that and we can see the image we drew shows up. And this will now also show up for all the other users of our app if they go to the cloud screen. We can also open this image up and make some edits to it. We'll just make the whole thing purple, and then if we save to cloud, we will see that once again it's still saved locally, but then in the cloud it is also updated. So you can still edit your cloud images and other users can see those changes. Those are the major features of our app. So